I'm here to present the Envelope, the second StreamD project funded through the last year's call. I'm Lazaros Gkatzikis, and I'm representing ICCS. So, some general facts about our project, as kindly introduced also by Chiara. This was targeting the Horizon JU SNS 2023 call, StreamD, on SNS large-scale trials and pilots, and in particular the priority one on connected and automated mobility, and how 5G can enable this vertical and expand the services related services supported. So overall, as you can see on the map, we cover a large part of Europe. We are 23 partners, and we are utilizing and further developing 3 living labs, one in Greece, one in Italy, and one in Netherlands. And overall, we involve partners from 10 member state countries. And the overall budget of the project is almost 16 million euros, with 2.7 of them dedicated to open calls that will come up at the later stages of the project, and will be utilizing the advancements that Envelope will deliver. It's a typical 36 months duration. As all projects, we started this January, and we will run up to 2027. Moving on, we would like to present the motivation behind our Envelope project, and this is that we have realized that the main barrier of the further uptake of 5G use by verticals is that it requires a very demanding interaction and knowledge about how the system itself works and interacts. So in this sense, what we are trying to apply with Envelope is transform the reference 5G advanced architecture into a vertical-oriented one, and one that will provide the necessary interfaces that will be tailored to the SICAM use cases, but not limited to them, and that will enable us to expose the network capabilities to the verticals. We will enable us, on the other hand, for the verticals to provide vertical level information to the network, and last but not least, will enable dynamic reconfiguration of the network requested by the verticals themselves. And all this, we aim to achieve them in an open, transparent, and easy to use semi-automated way, meaning that the verticals should have the means to easily interact with the network, not through the complicated interfaces specified in, for example, 3GPP, but through abstractions that can be provided by the envisioned Envelope APIs, and overall automate the procedures to the extent possible that will materialize what the verticals want to use the network for. So in a nutshell, as you can see in the figure, the design principles are that we depict in gray whatever is kind of standardized 5G based, and what we depict in colors is contributions that Envelope aims to achieve. As you can see here, and I mentioned already, one major contribution of Envelope is to devise, design, and expose APIs that will be easy to use by the verticals, and this spans the whole architecture from the application layer at the UE side up to the Envelope APIs at the server side, located at the data network or on the edge. On the other hand, we have a tight integration of MEC in the overall architecture of Envelope, and for the upper layer, we have network and service management, automated interacting with the network and configuring it on the fly based on intents. So all in all, we are trying to achieve an easier to use network by the verticals. And as we say in a nutshell, Envelope aims to develop an envelope that can cover, accommodate, and support any type of vertical service. So in more practical terms, what this means is that what we want to do is that we want to not only advance, but also create an open version of the reference 5G advanced architecture. And by open, we mean that we're trying to develop the open versions like Open 5GS and Open Air interface further to support basic functionalities needed by verticals. And this will hopefully result in a dynamically configurable beyond 5G system that can be reused not only for experimentation, but also in the field, as it will be supporting tight interactions and a tighter integration with a vertical domain through NEF and PCF services developed within the project. As a second objective of the project is that we want to expand on the CAM services that can be developed and supported by such a network. And in this sense, what I mentioned before is that we aim to develop and design the vertical-oriented, open, transparent, and easy-to-use interfaces that will span both the network and the service side. On top of this openness and advanced functionalities that have been standardized by 3GPP up to release 17, 18, Envelope aims to advance key beyond 5G technologies that we consider critical for the CCAM services. And these have to do with automation and improved user experience. Indicatively, we are targeting ATSSS, a functionality related to multi-connectivity standardized from release 16 up to release 18 in 3GPP, predictive QoS, which is an active work item related to CCAM in 5G AA, and finally, zero-touch management. These are indicatively, and it's not a non-exhaustive list. On the other hand, what we have realized is that for CCAM services, MEC integration and cross-domain east-west bound coordination across different MEC providers is a critical part that has not been implemented or standardized enough so as to find its way to the market. And this would involve different stakeholders. It involves interaction of different MEC providers, but also the interaction of a MEC provider with the MNO or the MNO itself if it provides also MEC facilities. And the objective, one objective related to this activity is that we aim to advance is network-assisted service continuity. Finally, as it is a large-scale project, SNS Stream D, we aim to demonstrate the capacity of Envelope to accommodate this variety of services, not only CAM, CCAM, but also from other verticals that will be coming through the open calls that we will be having throughout the duration of the project, to experiment on the three advanced developed beyond 5G infrastructures. So, in a nutshell, I will just describe the three sites, the objectives or the targets of the three sites. So in Italy, it is
1 minute, Lazarus.
Yes, that has to do with emergency. We are talking about vehicles moving in the real roads, on the real roads, and we aim to achieve that the network will be operating as a distributed black box of what is happening on the roads. And for this purpose, what we consider important is that we need to investigate further what happens as the cars move from one MEC to another and the corresponding east-west bound interface interactions. In Greece, we consider how the vertical will be able to provide information to the network itself, and especially in challenging scenarios, roaming scenarios, where we move from one PLMN to another. In our case, this is moving from the PLMN of Cosmote to the NCSRD private PLMN. Finally, Netherlands is focused on the application and use case of digital twin. We want to recreate the physical world in a digital twin that can accommodate all the functionalities and represent reality in a realistic way in the digital equivalent. So all in all, that's our objectives in envelope. Thank you very much. You can find my contact details here, and our communication manager is Anna Zanetti from Ethical.